In this session, we are going to discuss describing the data using summary statistics. We are using Rice University's website on simulations and demonstrations. Specifically in this session, we are using the demo called mean and median demonstration. So we'll be focusing on three things on the screen here. We'll be focusing on the histogram here, the blue graph here. And then we'll be focusing on the summary statistics on the top left-hand corner here. So in this example, n equals 25, so sample size is 25, and mean, median, standard deviation, skewness. Then on the bottom, there are 5 columns. We will be focusing on the first 3 columns. The first column is the actual raw data. The second column is the raw data, the deviation of the raw data from the mean. The third column is the deviation square. Okay, so here there are 25 data points. Let's pretend that this is a class of 25 students, and we are gathering the quiz scores of these 25 students. So the scores range from 1 through 9, and the first column here is the raw data. For example, the first student got a score of 1, second student got a score of 2, third student got a score of 2, and so on. If you scroll down, you get to see all the 25 scores. And the bottom row here are the mean. So the mean of all these 25 data points is 5. The second column here, the deviations for the first student, x minus the mean, 1 minus 5 is minus 4. And then you take the deviation of their score from the mean for all the 25 students, take the mean of all those deviations. You will see that that's always going to be 0. And then the third column is we are squaring the deviation. So minus 4 squared, that's 16, minus 3 squared, that's 9, and so on. So for every student, we compute the deviation square, add them up, and then divide by n minus 1. So that is the variance is 4. Then you take the square root of 4, that's a standard deviation, that's what you see up here. So for this data set, the mean is 5, the median is 5, standard deviation 2, skewness is 0. And then mean and median, or the measures of central tendency, and the standard deviation is a measure of variation, how much variation in the score. Skewness measures whether the data set is symmetric or not. If it's symmetric, the skewness measure is going to be 0. And then if it is not symmetric, then the skewness measure will be either a positive number or a negative number. So in the histogram, what we are plotting here on the x-axis is the x value, or the data value, or the score, in this case 1 through 9 score. And the y-axis, we are plotting the frequency, the number of students, or the frequency. For example, the most frequency is 5. 5 students got a score of 5, and 1 student got a score of 1. Okay. So in the symmetric distribution, mean and median both are equal, and then the mode, which is not shown here, but the mode is also 5. So mean, median, mode, all of them are 5, skewness is 0, and standard deviation 2. So the first, we are going to demonstrate the standard deviation. So remember the number 2. So let's say that I told you it's a measure of variation. So let's say I've got less variation in the data. So that means that I don't have scores of 1 and 2. I don't have scores of 8 and 9, for example. So all the scores there are 19 students. All the scores are between 3 and 7. Before it was between 1 and 9. Now it is between 3 and 7. So you see the standard deviation has gone down. It's 1.3. So let's say that the scores are even tighter than before. So now I've got 13 students, and the scores are 4, 5, and 6. So they are even tighter, less variation in the scores. Now you see the standard deviation even has gone down further, 0.78. So now let's say that I have only 5 students in this class, and they all got a score of 5. Then you see the standard deviation 0. So if there is no variation in the data, then the standard deviation is going to be 0. So let's say that I've got 5 students in my class, but all of them got a score of 9. So again, standard deviation is actually 0. So again, mean, median, mode, they're all equal. Standard deviation is 0. Skewness is 0 because there's absolutely no variation. Okay. So if I have these, again, 5 students, they all got a score of 1. Again, there's no variation in the data, so the standard deviation is 0. Again, mean, median, mode, everything equal to 1, and skewness is 0. So now let's make this data a little bit more interesting. So let's say this exam was very, very hard. So a lot of students got very low score, but there are some students, let's say they got high scores. Okay, so this distribution is kind of skewed, and we've got a very, very long right tail, so it's called a right skewed distribution. And there is the measure for skewness is 0.93, so it's a positive number. So sometimes it's called positively skewed, right skewed, because the long tail is on the right hand side. And the standard deviation is 2.43. Again, you see there's a lot of variation, 1 through 9. The scores are 1 through 9, a lot of variations. So standard deviation 2.43. And the mode here is 1 because 5 students got a score of 1. So the mode is 1. The median is 3. So half the students got score more than 3. Half the students got score below 3. So the median is 3. And the mean is 3.42. Even though a lot of students got scores 1 and 2, the mean is skewed towards right here, 3.42, because there are a lot of students got high scores, so the mean is dragged to the right, so mean is 3.42. So you see the pattern that the median is in between the mode and the mean, and that's always true. So let's make this distribution interesting on the other side. So let's say, this exam was pretty easy, and so a lot of students got very high scores, but some students got very low score. So in this case, we call this left skewed distribution because there's a long left tail, and the skewness measure minus 0.93, so sometimes it's called negatively skewed distribution. And standard deviation, again, is 2.43 because we still have a lot of variation, 1 through 9. And even though a lot of students got 8 and 9, you see the mean is 6.58. Mean is dragged down because there are a lot of outliers on the low end, so the mean is dragged down. So the mean is 6.58. The median is 7. But if you look at the mode is actually 9. Frequency of 5. The most frequency is actually 9, so the mode is 9. Again, you see that the median is in between the mean and the mode. Okay, so in summary, we explained the standard deviation, the measure of variation. We explained mean and median and mode, which are the measures of central tendency and also skewness. Thank you.